Hello students, today through this video we will discuss few questions on structural analysis. So in this video we will discuss some basic questions across which you may come during your interview or during your oral examination. So let us start the video with first question. What is the exact difference between moment and bending moment? So friends, in engineering mechanics we are calculating moment of force about a point or moment of number of forces about a point or summation of moment about a point. So what is meant by moment? And in mechanics of structures we are using this term bending moment. So moment means it is the product of a force and displacement. It is the product of force and displacement. Moment is calculated about a point. So if you read the statement carefully, the question will be like this: calculate moment of a force about point O, or what will be the sum of moments about point O or about an axis. So moment, it can be calculated about a point or about an axis. Moment of number of forces about a point is equal to algebraic sum of moment of all forces about a point. So if you are calculating sum of moments of number of forces about a point, then we have to add moment of individual force algebraically about that point. So in short, moment is nothing but product of force and displacement, and it is calculated about a point or about an axis. Now what is meant by bending moment? Bending moment is the unbalanced moment. Unbalanced, this word is important. Unbalanced moment calculated either to the right of a section or to the left of a section, while moment is calculated about a point or about an axis. Bending moment is the unbalanced moment calculated either to the right of a section or to the left of a section. Now what effect moment produces? Moment produces rotary effect, while bending moment causes bending of a member. For example, if you consider a flat which is pinned at say point A, this is point A, and if you apply a force like this on this flat, remember joint A or support A is a pin support. So we know the characteristic of pin support. About that support, member can rotate, and this is distance x. So this is the perpendicular distance between force F and point A. So if you calculate moment, now here we will discuss effect of moment. Moment is force into distance, perpendicular distance, F into x. So because of this moment, the member will rotate about point A in anti-clockwise direction. Now what is meant by bending moment? Let us consider a beam, say simply supported beam, support A and support B. Suppose this is load W, this distance say A, and this is B, and here this is distance x, or say N, length of beam AB. This is length A and this is support B. Now moment at support A is equal to W into A clockwise negative minus, sorry, plus VB into X. This is moment. Now what is meant by bending moment? Bending moment means sum of, or it is the unbalanced moment. It is the unbalanced moment about a point. Now again let us consider this is point C. Bending moment at C is equal to VB into B. Now while calculating bending moment at C or about at point C, we have to consider a section which passes through point C, and then we can take unbalanced moment either to the right of section or to the left of section. If I consider to the right of section, bending moment at C is equal to VB into B. If I consider to the left of section, bending moment at C is equal to VA into A. So it is unbalanced moment. You have to consider either to the right of section or to the left of section. And moment is product of force and displacement, and it is calculated at a point. Okay, here you can calculate moment, net moment about C, VB into B anti-clockwise positive minus VA into A. This is moment at C, moment of all forces at point C, and for equilibrium it will be equal to 0. But bending moment VB into B only. We are not considering VA into A. So this is the difference between moment and bending moment. Bending moment is the unbalanced moment either to the right of section or to the left of section. Now let us consider the second question. Figure shows a cross section of beam. So this is cross section. This is cross section of a beam. It is a T section and L section of a beam. In this figure, A, B, C, D, etc. These are the connectors which are used to connect the flange. This is flange of a beam and web. This is web. This is web. Connect the web section and the flange section. So here in this figure in cross section you can observe the shear connector. This vertical black line is shear connector or connector as stated in the problem, connector only. Okay. State for which type of force these connectors should be designed. So see the answer. When a beam is carrying external load, suppose we are having a homogeneous beam like this. This is the neutral axis of the beam, and if beam is carrying a vertical load like this, because of this load the beam bends with convexity downward. Here also the beam will bend with convexity downward. But during bending, since the flange and web both are connected to each other, there will be sliding of this flange section and web section along this interface or along this joint. So this is interface, this black line is interface. There will be sliding of flange section on the web section. Okay, and because of this sliding, this is nothing but development of shear along this interface. There will be sliding between flange and the web, and it causes development of shear stresses. Now to place the flange and web intact, firmly connected to each other, these connectors are used, A, B, C, D. Now you can imagine all these connectors are subjected to shear. All these connectors are subjected to shear, and that's why these connectors should be designed for shear force. These connectors should be designed for shear force. Now here we can consider single shear failure. Suppose this is the top plate and this is the bottom plate. These two plates are connected with the help of a shear, with the help of a rivet. This is lap joint. On this plate, force is acting to the right. On this plate, force is acting to the left. Now here also shear stress will develop, and the rivet is subjected to shear, and this rivet we have to design for shear along this plane. Same is the case with the shear connectors, and hence these shear connectors should be designed for shear. So this is the correct answer. Next, What is the difference between a truss and a frame? Now here this figure, it shows a truss. This is truss and this is frame. Both are the structures which can support the external load. The only difference between the truss and the frame is truss can carry load at the joints only. So this particular truss is carrying load at B, load at D, load at H and load at G. So this structure is carrying load at joints only. While in case of a frame, frame can carry load anywhere. So here 10 kilonewton per meter load is distributed on this beam, horizontal member, while there is a point load of 10 kilonewton acting on this column. So frame can carry load anywhere, but truss can carry load only at the joint, and that's why the members of a truss, they are subjected to either tension or compression, axial forces. For example, this member, let us say in tension, this is in compression. So members are carrying axial forces only, either tension or compression, while the members of a frame, they are subjected to shear and bending, because here, because of such load, the members are subjected to bending, members are subjected to bending, and hence bending stresses are developed in the members along with shear forces, so this is the difference between a truss and a frame. Now question number 4. A member is simply supported at the near end and fixed at the far end. What is the stiffness of the beam in this case? We know in case of a beam, we are defining stiffness or rotational stiffness like this. It is the moment required to produce unit slope at that joint or at that support. So in the above case, the moment required to produce unit slope or unit rotation at A is equal to 4EI upon L, and this is the stiffness of this beam. While if near end is simple and far end is also simple, in that case the stiffness is equal to 3EI upon L. Or one can write this 4EI upon L as EI upon L and the second stiffness as EI 3 by 4 EI upon L. So the correct answer is 4EI upon L. Now question number 5 is having some options. I will read the question. This is statement number 1. Moment causes rotation of a joint. Moment causes rotation of a joint. We have to select correct statement. Force causes displacement of a joint. Force causes displacement of a joint. Torque causes rotation of a joint. And fourth statement is all of above. All of the above. So which statement is correct? Options are given. Only A is correct. A is moment causes rotation. Only B is correct. B is force causes displacement. Both A and B are correct. Fourth is both B and C are correct. And the fifth is D is correct. So which statement is correct out of these four statements? So for this, to answer this question, we must know the cause-effect relationship. Cause-effect relationship. So cause-effect relation is, when we apply a force, displacement is bound to be there. When we apply a moment, there must be a rotation. When we apply a torque, there must be a torsion. So this is well-known cause-effect relationship. This is well-known cause-effect relationship. So force is the cause, its effect must be displacement. If moment is the cause, its effect must be rotation. If torque is there, its effect must be torsion. And that's why the correct statement Here the correct statement is moment causes rotation, moment causes rotation and force causes displacement of a joint. So the second statement is correct. Here I have written 3. This is wrong. The second statement is correct. The second statement is correct. Hence the correct option is number, sorry, it is correct. Correct option is, the correct option is statement number 3. What is statement number 3? Option, in option statement number 3 is both A and B are correct. Both A and B are correct. A and B are correct. What is A? Moment causes rotation. What is B? Force causes displacement of a joint. So instead of 1, 2, 3, here we can say this is A, this is B, this is C and this is D. So statement A and B both are correct because moment causes rotation and force causes displacement, and hence statement number 3 or option number 3 is correct. Both the statement A and B are correct. Question number 6. What is the use of influence line diagram? Now here this figure shows influence line diagram for a simply supported beam. For a simply supported beam. So this is support A, this is support B, and on this beam unit load is rolling from A to B. Now as this unit load, it rolls from A to B. This is not a stable or static load, but the load is moving from A to B. As this load moves from A to B, the quantities like reaction at A, reaction at B, shear force at a particular section, bending moment at a particular section changes with the change in position of the load. So all these functions, shear force, bending moment, reactions, all these functions, they changes their value as the load is moving from A to B. Now to study this effect, we are plotting in ILD, that is influence line diagram. So our question is, what is the use of ILD? Influence line diagrams are used while designing beams, trusses used in bridges, crane rails, conveyor belt, floor girder and other structures which are subjected to moving load. So when a structure like beam is subjected to moving load, we are using influence line diagram. Now it uses the influence line diagram. It shows where or at what location the load will create the maximum effect for any of the functions such as reaction, shear force and bending moment. So the influence line, it shows at what position of the load a particular function, say shear force at a section, bending moment at a section, will be maximum. So while designing beams, trusses used for bridges, cranes, conveyor belt, we are using influence line diagram to locate the position of rolling load for which the required function will have maximum value. So this is the use of influence line diagram. Question number 7. In case of analysis of propped cantilever beams or say indeterminate structure, in addition to equilibrium conditions, an additional equation is required. For the beam shown in figure, which additional equation you can use? So this is indeterminate beam. Now friends, if I ask you to calculate the support reactions for this beam, so in this case, how many reactions are there? First horizontal reaction at A, second vertical reaction at A, then a fixed moment will be there and reaction at B will be there. So total there are 1, 2, 3 and 4 reactions, and we are having only 3 equilibrium equations. So this problem cannot be solved using conditions of equilibrium alone. So this problem is called as indeterminate problem. Now in this case, to find the support reaction, the redundant reaction, we have to use one more condition, because now we are having three equations and four unknowns. So we need one additional condition or one additional equation, and that equation is called as compatibility equation. And that to develop that equation in the given beam, we can use the additional condition as deflection at support B, that is YB, that is YB, deflection at B is equal to 0. Deflection at B is equal to 0. So this is the additional condition which we can use to analyze this beam. Once the reactions are known, we can plot SFD and BMD for the given beam. So the additional equation is compatibility equation of displacement, that is YB is equal to 0, and thus we will be having one compatibility equation plus three equilibrium equation, total available equations 4, and 4 unknown reactions. So this problem can be solved and it can be analyzed. So this is the answer of this question number 7. Question number 8 is state Castigliano's theorem used for the analysis of indeterminate structure. Used for the analysis of indeterminate structure. Now Castigliano's theorem we can use for determinate structures as well as for indeterminate structures. So what form of Castigliano's theorem can be used for indeterminate structure? So this is the equation of Castigliano's theorem. So this theorem states that the partial derivative of the total strain energy stored in a beam, partial derivative of the total strain energy stored in a beam with respect to the redundant force is equal to 0, because the redundant force it appears in indeterminate structures only. So the partial derivative of the total strain energy stored in a beam with respect to the redundant force is equal to 0. This is Castigliano's theorem. Now if you write Castigliano's theorem in mathematical form, it will be like this: displacement at and corresponding to the redundant. Now in this figure I have considered VB as redundant reaction, and now my first job is to find this reaction VB, and then I can calculate other reactions and I can analyze the beam. So I have selected VB as redundant. So displacement at and corresponding to the redundant is equal to partial derivative of total strain energy with respect to that redundant. So redundant is W. So the mathematical form is integration from 0 to L m upon EI, where EI is flexural rigidity, m is bending moment at a section, into dabba m by dabba w into dx must be equal to 0. Must be equal to 0. So this is the Castigliano's theorem for analysis of indeterminate structure. If you are using this theorem for determinate structure to calculate the deflections, then the right hand side will be replaced by quantity or magnitude of that deflection. Magnitude of deflection at that point. But here we are using this theorem for analysis of indeterminate structure. So right hand side will be equal to 0. So this is Castigliano's second theorem in fact. First theorem we are using for determinate structures. So after knowing W, we can calculate other reactions and we can plot SFD as well as BMD for the given beam. This theorem, Castigliano's theorem, is also called as a theorem of minimum work, and it can be stated as either you write this first part or redundant reaction forces in a statically indeterminate structure will be such that it makes the strain energy to its minimum value. To its minimum value. So this is the answer for question number 8. Question number 9. Change in temperature causes stresses in which type of structure, determinate or indeterminate? Why? So let us consider here two beams or two members. First, a bar is firmly fixed in between the supports. Let us assume that the initial temperature of this bar is 20 degrees centigrade or Celsius and the bar is heated to 100 degrees Celsius. Now because of increase in heat, what will happen? The bar will try to expand. But since it is firmly fixed at its ends, these supports prevent the expansion of the bar and thus it creates stresses in the bar, compressive stresses in the bar. So these are the temperature stresses and this structure is indeterminate. If I ask you to calculate reactions at A and B, you cannot calculate the reactions using conditions of equilibrium alone, but in addition to that, you have to use one more additional condition, that deformation of this bar because of change in temperature is equal to 0. This is compatibility condition and then only you can calculate the reaction. So this is indeterminate structure. In this type of structure, there will be thermal stresses if there is change in temperature. On the other hand, let us consider a bar which is placed on a table, frictionless surfaces. There is no friction between the bar and the table. And now the bar is heated from 20 degrees Celsius to 100 degrees Celsius. So this bar is free to expand. This bar is free to expand. Its length will increase. There is no restraint to this bar. And hence there will be no stresses in this bar. This is determinate structure. Okay, so temperature stresses are developed only a structure like this, indeterminate structure, because of the degree of freedom is restricted by the reactions or by the support conditions. And the last question is match the pairs. So column A, in column A it is written slope, bending moment, shearing force and rate of loading. In column B some equations are given. These are the elastic equation. These are the equations mentioned in column B and we have to match the pair. So slope, when we are using Macaulay's method to calculate deflection of a beam, determinate beams, we are using Macaulay's method, and the left hand side of Macaulay's method is EI into d2y by dx square is equal to bending moment, So this form of equation we are using in Macaulay's method, right hand side. Left hand side, EI into d2y by dx square is equal to bending moment. So bending moment is equal to or is represented by EI into d2y by dx square. Okay. Similarly, slope, we are using letter y for deflection. If you take first derivative of this y with respect to x, that is dy by dx, you will have slope. Okay. Again, if you take second derivative of this y, or if you further take derivative of this term, it will be d2y by dx square, which is equal to bending moment. Again, if you take derivative of d2y by dx square, you will have shear force. And again, if you take derivative of shear force, you will have a rate of loading. So the pairs can be matched like this: slope EI into d2y by dx, dy by dx, bending moment EI into d2y by dx square, shearing force EI into d3y by dx square, and rate of loading is equal to EI into d4y by dx4. Or alternatively, you can say like this: if you integrate this equation, rate of loading, you will have shear force. If you integrate shear force, it will give you bending moment. If you integrate bending moment, you will have slope. If you integrate slope, you will have deflection. You will have deflection. So this is the correct answer for question number 10. So this is all about the fundamental questions, few fundamental questions from structural analysis. So in the next video we will again meet to discuss few more things related to the subject. Thank you.